Hi everyone! Welcome to my YouTube channel. Today our math lesson and tutorial is on finding the domain and range of rational functions. This is the part 2 of the discussion in determining the domain and range of the rational function with the reference of the vertical and horizontal asymptote, together with the point of discontinuity. Again, this is Null and Null Math Learning sa YouTube channel. The general rules in determining the domain and range of rational function. If factorable, express the numerator and denominator in factored form. Kasi mas kailangan or maigi na naka-factored form ang given function. For the domain, determine the x value in the denominator either as point of discontinuity or the value of the vertical asymptote. This serves as restricted value of the domain. For the range, determine the value of the horizontal asymptote or the value of point of discontinuity. We will use here the cases of horizontal asymptote, and this serves as restricted values of the range. The first case of horizontal asymptote if the numerator and denominator have the same degree, so we will just divide the leading coefficient of the numerator and the denominator. So that's the restricted value of the range. Or, if the degree of the numerator is less than the degree of the denominator, the restricted value of the range is simply y equals 0. Or, if the degree of the numerator is greater than the degree of the denominator, there is no restricted value most of the time, or there is a y value of point of discontinuity because it will form a point of discontinuity. We have different forms or ways in writing or describing the domain and range of the rational function. First, by roster. This is by enumeration. We have the example for the domain. This is the form. Domain equals the set of 1, 2, 3, 4, and so on. The range is the set of 1, 2, and so on. Then another is by set builder notation. So we will be using this. So we have the form, the set of all x such that x is blank. Example, we have the domain as the set of all x such that x is an element of real numbers when x is an element of integers. Same for the range. Range is the set of all y such that y is an element of real numbers where y is an element of integers. Another is by interval notation. So we will be using also this one, number 2 and number 3. So we will use this as our answer in determining the domain and range of rational function. We have the open interval from smallest number to largest number, closed interval. We have the half open interval, and we have the half closed interval. For example, we have the domain is equal to a half closed interval from 1 to infinity. Our range is half open interval from negative infinity to 1. Let's proceed to example. Find the domain and range of the rational function f of x equals 4x plus 1 all over x minus 2. Our solution, our given function is 4x plus 1 all over x minus 2 equals f of x. For the domain, you will get the denominator which is x minus 2. Take note, our reference for the domain ay lahat ng terms na nasa denominator, you equate it to 0. Kung hindi na siya factorable, so you solve for x for the denominator, and that's the restricted value of the domain. That's also what we call the vertical asymptote. So we have x is not equal to 2. Therefore, the domain we have the set of all x such that x is not equal to 2. Or we can write it in interval notation. We have an open interval from negative infinity to 2 union open interval from 2 to positive infinity. For the range, so we will determine the horizontal asymptote. Since the degree of the numerator is 1 and the degree of the denominator is also 1, meaning same degree, what will you do is just get the leading coefficient, 4 for the numerator, 1 for the denominator, and you divide it. So therefore, y is not equal to 4 over 1 or y is not equal to 4. This is the restricted value of the range. Therefore, how to write the range? The set of all y such that y is not equal to 4. Or, that is, an open interval from negative infinity to 4 union open interval from 4 to positive infinity. I'll repeat. When the given function have the same degree, you just get the leading coefficient of the numerator, divide the leading coefficient of the denominator. And that value is the restricted value of the range. If that is a range, so we use the variable y. Y is not equal to 4, and that is the range. For the domain is the denominator, the value of the denominator. The value of x of the denominator is the restricted value of the domain. Let's proceed to example number 2. Suppose we have the given function 4 over x plus 1, which is equal to f of x. What is the domain and the range of the function? We have the given f of x equals 4 over x plus 1. For the domain, just get the denominator, which is x plus 1, and that is not equal to 0. So we use the symbol is not equal because that's not part of the domain. So we have x plus 1 is not equal to 0. Transpose 1 to the other side, it became negative 1. Therefore, the domain are all real numbers except x equals negative 1. So, or x, the domain is the set of all x such that x is not equal to negative 1. Or we have, from using interval notation, that is from negative infinity to positive infinity. Union from negative infinity to positive infinity. How about for the range? So the range is the degree of the numerator is 0 because there is no variable. The degree of a constant is 0. And the degree of the denominator is 1 because there is a variable and no exponent. It means the exponent is 1. So 0, 1. So meaning the degree of the numerator is less than the degree of the denominator. Therefore, it's always y equals 0 as the value of the horizontal asymptote, and that serves as the restricted value of the range. Therefore, y is not equal to 0. So therefore, the range is the set of all y such that y is not equal to 0, or from negative infinity to 0, union, open interval from 0 to positive infinity. Another example, we have find the domain and range of the rational function f of x equals x over x squared minus 9. For the domain, take note that the given function is factorable. We need to factor. So I told you that the first step, general step, is to factor if it is factorable. Since the denominator is factorable, so you need to factor it. And equate the denominator to 0, solve for x. So we have x minus 3 is not equal to 0 and x plus 3 is not equal to 0. Therefore, x is not equal to 3 and x is not equal to negative 3. So therefore, the domain is the set of all x such that x is not equal to positive 3 and negative 3. Or we have an open interval from negative infinity to negative 3, union, open interval from negative 3 to 3, and union, open interval from 3 to positive infinity. Because we have two not included in the set. For the range, the horizontal asymptote, we have the degree of the numerator, which is 1, and the degree of the denominator is 2. Therefore, the numerator is less than the denominator, so y is equal to 0. Is the value of the horizontal asymptote. And this serves as the restricted value of the range. So y is not equal to 0, so we have y, the set of all y such that y is not equal to 0, or we have from negative infinity to 0 union, open interval from 0 to positive infinity. So we have another example. Find the domain and range of the rational function. We have x squared plus 2x minus 1 all over x minus 1, which is equal to y. Our first step is to factor the numerator. X squared plus 2x minus 3 is factorable by qt-1. Okay, quadratic trinomial where a is not equal to 1. So, gagawin natin, gawa ka ng dalawang parenthesis, get the square root of x squared. We have xx. Since the last term is negative, isang negative, isang positive. The middle term is positive, meaning yung malaking factor ay positive. When you multiply is negative 3, but when you add is positive 2. So, 3 minus 1 is 2. So, meaning this is the correct factored form of the given expression x squared plus 2x minus 3. Next is, to get for the domain is, you get the denominator. The denominator is x minus 1. And you solve for x, so x equals 1. So, ang x equals 1 is a restricted value of the domain. So, we use the inequality symbol. So, x is not equal to 1. This is one point of discontinuity. Why point of discontinuity? Because x minus 1 is common to numerator. It's a point of discontinuity on the graph. Therefore, our domain is the set of all x such that x is not equal to 1, or that is an open interval from negative infinity to 1 union, open interval from 1 to positive infinity. For the range, so we have the horizontal asymptotes. Since the degree of the numerator is greater than the degree of the denominator, so therefore there is no horizontal asymptote. But there is a point of discontinuity kasi may kinancel tayong common factor. Once na may kinancel kayong common factor, meaning there is a point of discontinuity. I said, to solve for x of a point of discontinuity, just solve that factor na kinancel for x. Yung x minus 1 equals 0. So, x equals 1. Yung 1 ay isusubstitute sa remaining factor na natira sa function. Ang natira na lang dito ay x plus 3. So, we have x plus 3 is not equal to 0. So, therefore, we substitute here x to solve for y. Remember, y is not equal to x plus 3. X plus 3 ang natira na lang sa function. We substitute when x is 1. So, 1 plus 3 is 4. Therefore, y is not equal to 4 as the restricted value of the range. So, the range is the set of all y such that y is not equal to 4 or an open interval from negative infinity to 4 union open interval from 4 to positive infinity. Thank you. Please watch for the upcoming video on asymptotes, intercepts, and zeros of rational function.